At the beginning of the fall 2024 semester, our Purdue AAE 418 team was assigned to the Softgoods Attachment Device Challenge, part of the NASA Micro-G NExT program. Our mission? To design and prototype an EVA tool that could attach two overlapping pieces of softgoods while accessing only one side of the material. Our solution? A point attachment fastening device that we called the SNARE. During the conceptual design of our tool, we successfully tested a commercial, off-the-shelf proof of concept while simulating neutral buoyancy at the Indiana University dive pool. And it worked. We also took our mission beyond the lab. Through a STEM engagement event, we reached over 150 middle school students at Wilbur Wright Middle School, successfully teaching them about neutral buoyancy and its application in space, as well as the importance of designing with ergonomics and human factors in mind. We challenged them to make a water bottle nutri-buoyant with both limited time and resources, and boy, did they rise to the occasion. At the end of the fall semester, we submitted a proposal we were proud of, with a strong design, a successful outreach event, and a solid plan for testing at NASA's Future Buoyancy Lab. But NASA didn't select our proposal. Still, our journey didn't end there. We adapted, we grew, we persevered. We are Purdue SNARE, and this is our story. Prototype after prototype after prototype. Rework after rework. Until we had achieved perfection. But we still had to test it, and without NASA's help.
When we initially decided to go it ourselves without NASA and without the actual NBL testing as the target, I had some concerns about this issue. And as we progressed, I could see that our emulation of how NASA conducts business with design reviews and progressive design revisions was matching the NASA model very well, actually in some ways with less overhead and advantage. And I thought you did actually every bit as well as the actual NBL test would have been. The communications were kind of rough because the gear is less expensive professional underwater gear. The imagery wasn't as perfect, but nevertheless, you overcame each of those potential deficits and in some ways turned them into strengths. Is what good teams do.
It's pleasing to me how the team persevered and worked through 2 semesters and not only delivered a very successful tool in this tool challenge, Spacewalk Tool Challenge, but they also created their own testing infrastructure and testing setup and worked through that independently of NASA and achieved, as I can see, pretty much all the goals of the program. And that's really remarkable in my 28 years of this style of teaching. I don't think a team has done both the tool and the testing setup and infrastructure themselves. So a good batch of work.
Given the constraints of doing testing underwater, where it has differences from space, you understood those constraints. We went over them as the year progressed, and they were implemented. And the final tool met in every way what I thought was a proof of principle, even beyond that, a proof of operational capability. Of course, you don't build it out of titanium at Purdue on the first try, but it is ready to immediately be translated with minimal design changes into an actual EVA tool. And it's an important tool to do this kind of fabric repair. The space station is essentially the outside exterior is made out of fabric. Myself have been outside and had these fabrics come loose and flapping in my face. And then I've seen the Velcro not work anymore in some older areas. And they could have benefited by this tool being available on the during EVA. So it's an important tool. It worked right, and it's ready for transfer and translation to actual spaceflight hardware, which is our goal in this course. It's more than a course, actually. It's a true engineering achievement that each year is produced.
Team ended up being able to fasten together various fabrics of different thicknesses and strengths, and this was a neat improvement to watch over the original prototype, which operated on one fabric. And so when they iterated a couple times and came up with a really a great working design, and when I was tugging on the fabrics after their testing, it was impressive how well secured they were.
I thought your design was pretty complicated and a lot to bite off in the beginning, and you guys pulled it off, doing a lot of computer-aided design and manufacturing techniques, and you got the right answers and in a provable, demonstrable way, and I think it was a complete success in summary in terms of the process of leading up to the NBL as well as the actual final dive and test.